There is a world out there, adrift in the cold and the dark, that wears a crown of impossible beauty. For millennia, we have gazed upon it, a tiny, steady point of light in our night sky. But through a telescope, it becomes something else entirely. It transforms into a celestial jewel, a planet encircled by a magnificent, shimmering halo. This is Saturn, a gas giant of immense scale, yet floating with unmatched elegance. Its true nature is more complex than beauty alone, a story of cosmic violence, delicate balance, and the profound possibility of life. Saturn is the sixth planet from our Sun, a colossal ball of hydrogen and helium, so vast that you could fit 764 Earths inside it, yet the least dense of all planets. If there were a bathtub big enough, Saturn would float. Beneath that lightness, violence. Winds scream above 1,800 kilometers per hour. Storms larger than Earth rage for months. But what seizes our imagination are the rings. They make Saturn, Saturn. They stretch for hundreds of thousands of kilometers, yet are often thinner than a house, sometimes only 10 meters thick. From Earth, they seem solid, a grand illusion. Up close, countless pieces of ice and rock, from sugar grains to mountains, each in its own orbit. Inner rings race faster than outer rings. Collisions grind and ripple like grooves on a vinyl record. Ordered chaos. Cassini showed the rings are over 99% water ice. Their brightness hints they are young, too clean to be ancient. From Galileo's puzzling sketches to Voyager's ringlets to Cassini's revelations, every layer we peel back reveals deeper questions. To answer them, we crossed 1.5 billion kilometers into the heart of the Saturnian system, a place of staggering beauty and profound revelation. That's where the real surprises begin. To truly comprehend the rings, you must imagine yourself flying amongst them. The silence would be broken by a gentle rain of tiny ice crystals on your ship. You'd be surrounded by a blizzard of orbiting objects, a chaotic dance, tumbling and glinting. From here you see divisions and bands. D, C, the dense and brilliant B, then the A ring. Between B and A is the Cassini division, a gap 4,800 kilometers wide, visible from Earth. Each particle is its own tiny satellite, obeying gravity's laws. Inner rings circle in hours, faster than the outer rings, a constantly changing environment. Gentle collisions grind and stir, sending spiral waves through the disk like grooves on a record. This is a vast natural laboratory of orbital mechanics, ordered chaos at planetary scale. Cassini data. The rings are almost pure water ice, over 99%. The faint color variations come from a dusting of rock and carbon compounds. Over billions of years, dust should darken the ice. Their brightness suggests they might be young. Are they ancient, born with Saturn, or recent, a transient crown we're lucky to witness? The answer lies in the dust, the motion, the fabric of the rings. The evidence is there, waiting to be read. So we keep looking. How do you create something as vast and intricate as Saturn's rings? There are two leading theories. First, the primordial model, leftover icy debris from Saturn's birth, trapped within the Roche limit where tides prevent large bodies from forming. Inside this boundary, gravity tears apart would-be moons, keeping a diffuse ring. Second, a more dramatic idea. Young rings, perhaps only 100 million years old, a blink in cosmic time. A large icy moon or a stray comet wandered too close, crossed the Roche limit, and was ripped to shreds. Its debris spread into a brilliant disk. Cassini measured ring mass and dust infall, indicating they would darken within a few 100 million years. In its final orbits, Cassini detected heavy ring rain. The rings are draining away. At this rate, Saturn's halo could vanish in as little as 100 million years. So the rings may be a transient halo born from destruction, a short-lived masterpiece. Perhaps Jupiter and Uranus once wore such crowns, now faded. We live in a special epoch to witness Saturn at its most beautiful. a lucky accident of timing. It's quite astonishing when you think about it. Look closely. Sharp edges, gaps, wave patterns, a choreography with hidden conductors. Shepherd moons like Prometheus and Pandora confine the thin, braided F-ring, invisible hands keeping it from dissipating, pulling streamers and knots. Cassini found tiny propellers, wakes carved by unseen 100-meter moonlets. These baby moons mirror planet formation in protoplanetary disks. The rings are a living lab for cosmic creation. By studying them, we learn how worlds grow. And that's why we keep sending probes and listening closely. Beyond the rings, Saturn reigns over more than 80 moons. The undisputed king is Titan, bigger than Mercury and the only moon with a thick atmosphere, a hazy orange shroud. Cassini-Huygens revealed a world of rivers, lakes, and seas, but of liquid methane, with water as hard as rock. Methane evaporates, forms clouds and rains, carving valleys and filling vast seas like Kraken Mare. Winds sculpt immense organic particle dunes around the equator, a world with weather, seasons, and active geology. Beneath the ice, models suggest a global ocean. With abundant organics, Titan tempts the search for life. This is Enceladus, tiny, brilliant, and not at all dead. Geysers erupt from south polar fractures, feeding Saturn's E-ring, proof of liquid water and heat below. Cassini flew through the spray. Water, salts, organics, and silica nanoparticles. On Earth, such silica forms at hydrothermal vents. Enceladus likely has vents on its ocean floor. Liquid water, check. Energy, check. Organics, check. Perhaps the most promising place to find life today. The question is no longer whether it could support life, but whether it does. Mimas, nearly shattered by a colossal impact, wearing the Death Star look. Iapetus, one face bright as snow, the other dark as charcoal, dust swept and transformed by heat. Hyperion, a porous, tumbling oddball, low density and chaotic spin. Pan and Atlas, moons that wear the rings, ridges built by accreting ring material. Dione and Rhea, wispy scarps and icy cliffs, each moon a distinct story. Our modern understanding comes from Cassini-Huygens, a sustained presence from 2004 to 2017. It rewrote the textbooks, Huygens landing on Titan, Enceladus's plumes, propeller moonlets, ring waves and braids, and more. It watched storms encircle Saturn, measured the planet's day, and tracked Titan's changing seasons. Breathtaking images revealed avalanches on Iapetus, sunlight glinting on Titan's seas, and ring curtains shaped by moons. In its grand finale, Cassini dove between Saturn and the rings, sampling atmosphere and ring rain until it burned up like a meteor. We now think the rings are young and raining down. But how exactly did they form? A moon, a comet, and when? The rings are a crime scene. The evidence is there. We've just begun to analyze it. The next step is to go back, with instruments to seek chemical signatures of life, even a lander beside a tiger stripe. Imagine melting through the ice and sending a submarine into a dark ocean of vents. Not fiction, real goals for explorers. Dragonfly will fly Titan's skies, hopping dunes and shores to study prebiotic chemistry, maybe even exotic life in methane. Saturn has shown that water, organics, and energy aren't unique to Earth. They may be common. We're no longer only searching for Earth-like worlds. We're searching for other oceans like Enceladus. The jewel of the solar system has opened our minds and widened our horizon of possible homes for life. As we gaze into the darkness, our wonder burns brighter, with countless secrets still waiting. The journey has just begun.